The whole point about science is that you check your results against reality. And you need to learn, and it takes a lot of learning to sort of trust your own results and to learn how, when you're snooping around a problem, how do you find out what's going on? I think we should have more messing about and more fun.
More practical work?
Particularly practical work, you know, that every single thing that's in the book was hard won by somebody going through this process of discovery. That's what I would love to be able to convey. You know, you don't have to be particularly smart, you just have to be kind of a mixture of lucky and obsessed by the problem, I think.
So we want to open up, we want students to be scientists. We don't want to say, oh, well, you know, they've got to learn lots of stuff to enable them to know stuff, but actually, if they're doing science, they will realise what they need to know to be able to progress. And so they'll learn more about coding and developing systems for, you know, protocols for the data to come down. They will do it because they need to, and they can see they're part of the scientific community.
What do we want our children to know? What thinking skills do we want them to have? So we want them to know about scientific thinking, that is how to establish hypotheses and know the difference between opinion and facts and know about evidence. And we want them to know something about computational thinking as well, which is so that when they look at a flock of birds, they think, oh, is there a giant brain that's making all those birds move in that way? No, they might think, oh, perhaps each bird is operating a little algorithm in which they just look at the positions of nearby birds and do something, and somehow that collective behavior evolves. That's computational thinking. Now, I'd like children to be able to do that as well as scientific thinking.